Welcome back to the deep dive. Today we are going deep beneath the surface of large-scale manufacturing.
Yeah, looking at something huge but often overlooked.
Exactly, the choreography of raw materials.
Mm-hmm.
When you think about, say, cement production, your mind probably jumps straight to the big stuff,
The
right?
kilns, the
Yeah,
grinders.
the fiery kilns, huge preheaters, the mills, but way before any of that heat and crunch happened.
Before the really expensive bits.
Right. There's this complex ballet going on backstage. We're talking about storing, well, mountains of ingredients.
Limestone, clay, sand, iron ore, the basics.
And the challenge isn't just storing it. It's making sure those tons of material are blended perfectly
Absolute consistency, that's the key.
before they even enter the main process.
And that consistency, well, it's non-negotiable. That's our mission today, really.
Okay.
We're diving into the world of these industrial heavyweights, stackers and reclaimers.
The workhorses.
They really are. These massive machines manage the whole raw material storage operation. And crucially, they don't just hold stuff. No.
They perform that essential step of homogenization, the blending. So we need to understand why they're designed the way they are, look at the different types, and why this whole storage phase is, as you said, the first line of defense for quality.
And efficiency, frankly.
Okay, let's unpack this then. For someone new to this, stacker and reclaimer, they sound similar.
They do. Maybe like opposite ends of a simple conveyor belt.
Yeah. Or maybe even doing the same job.
Yeah.
What's the fundamental difference there in the yard?
They are definitely partners, but they do completely opposing jobs. It's right there in the names.
Okay.
The stacker, that's the builder, its job is to store,
Pile it up.
systematically pile up the incoming materials, but it doesn't just dump it, you know? It creates this uniform, layered bed.
Layered, okay.
Then the reclaimer, that's the preserver maybe, its job is to recover that material.
Yeah, get back out.
Exactly. Extract it from the pile and feed it onto the production line, making sure it keeps the quality of the stacker built in.
So the stacker builds this bed carefully, layer by layer,
Meticulously.
and the reclaimer takes it apart just as carefully, ensuring every slice, every layer is in the feed.
Precisely. And that's what's so fascinating. They're way more than just storage bins and scoops.
Right.
Their dual purpose makes them, well, foundational for efficiency. They give you high-density storage, and they're the main way you partially homogenize the raw stuff.
Like quality assurance before the raw mill even sees it.
Exactly. They're the plant's insurance policy against quality disasters.
That insurance policy idea is so important, because if that mixes off, your energy use later.
Oh, it skyrockets kiln efficiency tanks.
Right. So let's start with the stacker, the builder,
Yeah.
piling up limestone, clay, sand. How does it actually do that? How does it create that uniformity?
Okay, so material comes in fast on a conveyor belt system.
Right.
Stackers have this big dynamic boom arm. The machine itself usually travels along rails, and that boom directs the material, distributing it in continuous thin layers.
Thin layers are key.
Absolutely. It's all about controlled layering, spreading it over the whole footprint of the pile.
So variations in the incoming stuff get smoothed out.
Exactly. Any, high spot or low spot in quality gets averaged out across the entire volume, spread over maybe hundreds of meters.
That controlled layering. That sounds like the secret sauce. And you mentioned types. The choice of stacker matters for quality.
It really does. Not all stackers are built the same.
So what's the simplest type? And why would you even use a simple one?
That would be the fixed stacker. Just like the name says, the boom stays put.
Doesn't move.
Doesn't move. It's simple, it's rugged, pretty cost-effective to install and run.
Right.
But because it can't move up, down, or sideways, you get limited uniformity. It just forms a sort of cone-shaped pile or maybe kidney shape.
So why install one if it limits that crucial uniformity?
Well, it's a trade-off, isn't it?
Okay.
If you're a smaller plant, maybe your raw material is already super consistent.
Or you're just storing one thing.
Right, storing just one material type where blending isn't the main goal. Then the fixed stacker is, the smart economic choice. Why pay for complexity you don't actually need?
Makes sense. But if you need better blending, you step up to the luffing stacker. What's luffing? Is that like a sailing term?
Huh. Well, it is used in cranes and booms. Luffing just means the boom can pivot up and down.
Changing the angle.
Yeah, it changes its height or angle. And that lets the stacker form layers at different heights right across the pile's width.
Better geometry.
Much better stacking geometry. So that drastically improves the initial homogenization compared to the fixed type. You see these in medium-sized yards where precision starts to really count.
Okay, luffing is up and down. Now add rotation.
And you get the slewing stacker.
Slewing.
Yeah, the boom rotates horizontally. It slews around a central point.
So it can make circular piles.
Circular or semicircular patterns, exactly. The rotation gives it a much wider reach, makes it really flexible. This slewing, often combined with luffing, is why it's, well, probably the most common type you see in modern cement plants today.
Balancing footprint and blending.
Good balance, yeah.
And then for the really huge operations.
Yeah.
Massive throughput.
Then you need the beast, the traveling stacker.
The ultimate.
It's the large-scale option. If you've got a massive, long yard, really high production demands,
You need reach.
you need reach. The traveling stacker moves on rails along the whole length of the yard, and it often combines everything. Traveling, slewing, and luffing
Wow.
to manage multiple long, complex piles all at once. It's really the powerhouse of stacking.
Okay, this is where, for me, it gets really interesting. The stackers did their job, layered maybe tens of thousands of tons perfectly.
Terraforming.
Now the challenge, undoing that work just as perfectly.
Right,
Enter the reclaimer.
right.
Its job is recovery, sure, but its goal is that homogeneous, consistent feed for the raw mill.
That's the mission. The reclaimers are preservation mechanisms, in a way.
How do they work? How do they avoid just scooping off the top?
Well, their working principle is critical. They must remove material layer by thin layer across the entire face of the pile.
The whole width.
The whole width. To capture the full spectrum of what the stacker put down, if they just scooped from one spot, you'd completely defeat the purpose of layering.
Right.
So they use specialized tools, maybe a big bucket wheel or a scraper chain, sometimes a rotating drum, to pull the material back onto another conveyor.
Okay, let's look at the types. How do they maintain that blend? Starting with the one you said gives the absolute best quality control.
That is, hands down, the bridge type reclaimer. It's impressive. A massive bridge structure that literally spans the entire width of the pile.
Like a bridge over a river of limestone.
Pretty much. And underneath that bridge, you have multiple scraper chains working together.
Okay.
The whole thing moves along rails, reclaiming material evenly across the full width.
So it's not scooping, it's scraping the whole face at once. Like a giant squeegee.
Or, I like your earlier idea, a massive automated cheese slicer is a great analogy. Imagine that layered pile is like a giant layer cake.
Yeah.
The bridge reclaimer cuts a perfect vertical slice, top to bottom, side to side. Every single scoop or scrape contains a bit of every layer the stacker laid down.
Across all the layers simultaneously.
Right. Horizontally across all stacked layers at once. That gives you excellent homogenization. It's the gold standard for blending beds, especially for high-quality cement.
The gold standard. Okay,
Yeah.
what about the portal reclaimer then? How's that different mechanically?
The portal type, it usually has these rotating arms, sometimes called harrows.
Arrows, like for farming.
Similar principle, yeah. They sweep the material down on the side of the pile, usually onto a conveyor running alongside.
From the side, not spanning the top like the bridge. Yeah.
Exactly. You generally see them in long yards for those long, straight piles, often for limestone or clay.
And the blending.
Well, it's effective for recovering from those long piles, but it typically doesn't give you quite the same microscopic blending uniformity as the full-width bridge type.
Gotcha. Then there's the really visually impressive one. Looks like something from a sci-fi mining operation.
The bucket wheel reclaimer. Unmistakable.
Huge wheel with buckets.
A very large rotating wheel. Yeah, fitted with multiple buckets that scoop or cut the material away.
What's the key advantage here?
Speed and volume. Sheer throughput. It offers very high reclaiming capacity, runs continuously, very robust.
So for big plants.
Exactly. Large-scale plants needing to move a lot of material fast. Especially good for coarser stuff, higher volumes like iron ore, or maybe rougher limestone.
Speed and volume for coarse stuff. Okay. And the last type. The drum reclaimer. What's the trade-off here?
This one is about gentle handling and flow consistency rather than just speed or force.
Gentle.
Yeah, it uses a rotating drum, and it has scrapers attached that remove the material softly.
Why gentle?
The main advantage is it gives you a remarkably consistent flow rate and produces minimal dust.
Dust control.
Yeah.
Important.
Very.
Yeah.
So it's ideal for handling fine materials or stuff that's already pretty well blended, like certain sands or clays, where you want to keep that perfect mix without breaking it up or losing fines to the air.
So if we connect all this back, it's incredible how much complex engineering goes into just moving rock around.
It's far more than just moving rock, isn't it? It's about achieving chemical and physical precision using these massive mechanical systems.
Precision through mechanics.
Absolutely, because the selection of the right stacker and the right reclaimer system that fundamentally dictates the homogeneity of the entire raw mix fed to the plant.
The insurance policy again.
That's why it matters. A single deviation in that feed quality, I mean, it can easily add 3%, maybe 5% to the kiln's energy bill down the line.
Wow.
Not to mention the risk of damaging expensive refractory bricks inside the kiln or producing off-spec clinker that you can't sell.
So this careful layering and equally careful recovery, it ensures consistency.
Which is absolutely crucial for predictable results in those multi-million-dollar energy-guzzling stages later on.
So what does this all mean for you listening? It means these giant machines traveling, luffing, slewing, scraping, scooping.
These behemoths.
They're the silent architects of material consistency. They are foundational efficiency. They work together out there in the yard so the rest of the plant doesn't get clogged up, doesn't waste fuel.
And doesn't run into catastrophic quality problems because the input wasn't right.
They lay the groundwork for everything else.
They really do. We've kind of navigated the different shapes and jobs of these S&R machines. It's genuinely fascinating how much detailed thought, how much cost-benefit analysis goes into just the storage phase.
It really is.
Yeah.
And it's hard to grasp the scale until you actually see pictures or videos.
Absolutely. Which brings up an interesting question, maybe something for you, the listener, to think about.
Okay.
We said the drum reclaimer is ideal for fine, well-blended materials, gentle handling.
Right.
And the bucket wheel is for coarse stuff, high throughput. So how do constant fluctuations in the incoming raw material quality, like imagine a sudden rainy season making your clay really wet and sticky versus a long dry spell?
Operational reality.
How does that reality influence a plant's big, expensive initial decision? Do they invest heavily in a drum system for perfect blending or a more robust bucket wheel that can handle anything, even if the blending isn't quite as perfect?
That need for robustness versus precision.
It's a constant, expensive trade-off they have to make.
That's a perfect challenge to mull over. Really highlights how the real world shapes these engineering choices. We definitely encourage you to look up photos, especially that bridge-type reclaimer in action. The scale is just astounding.
It truly is.
Okay, until next time for another deep dive.
Thanks for following the channel, Courses in the Cement Industry. And please help us to continue and provide more information by subscribe to the membership and inviting your colleagues to watch this channel.